Hello everybody, hope you're doing great. Please check out the description box for all the nice links. Drop a like, subscribe, press the bell icon if you like the content, and check out the top right eye for even more nice links. Today is an amazing video. I really look forward to making this. We're gonna be creating the whole state system. So our engine is gonna be a state machine pretty much, and we're gonna have different Lua state files just like we have here, and each C++ state will be handling one of these files that we'll create. But we'll create a very general state class that can handle everything, and all our data is going to be stored in the states. It's very easy for us to create new states and switch between states. There's going to be a main stack in the engine that will control what is on top, and once that state is popped, the underlying state will become active. So just to show you guys, I have a little image here. So we'll have our C++ layer or our Lua layer. This can be our Lua layer, and this is our C++ layer. Now each Lua layer will be a file in itself. So you'll see these are different files here. I made this one a little big, I'm sorry. But in C++, we'll create different state objects here that will then in turn contain the data from each of these files. And these states will contain sprite data, they will contain texture data, they will contain maybe controls, all kinds of stuff. So this is going to be very nice. It's going to be very sectioned off here, and you'll see the beauty in this as we go along. You don't have to understand this completely just yet. Each state will be very independent from one another, and that's going to be really great. So let's show you guys how to do this. We have a Lua, a game state Lua here. Of course, we're going to make a function update end here, and this is how you create a function in Lua. You write the word function, the name of the function, the parameters, in our case this is empty right now, and then end. So that is our function. You can use these if you want, but I recommend not to. It's a little easier to just read it just like this. And then we're going to create a function render here, and this is only for our game state Lua. Now we're not going to do that much in here. We're going to print something out. We're going to say this is update. So whenever this function is called, there will be an update printed out, and then this will be render. Render will be printed out whenever render is called. Now our state is pretty much done. Don't forget to do this. This is perfect for testing. Keep in mind, we're only testing now. We're not doing any game related stuff. So next step for us is to remove the old Lua state stuff here. Go to your init Lua states, remove all of this stuff, remove the do file from init states, go to your engine.h, remove Lua, the main Lua state, and just keep it empty like this. Our next step is to right click here, add a new class, and this is going to be our main state class. There you go. I'm going to open up state.cpp here as well so we can see what's going on. Go into your state.h, and remember, each state is going to be independent from one another. We'll have some kind of state data that we can push back and forth if we want. That can be done later, but for now we don't need that. We only need states to be independent from one another. So that means each state will have its own Lua state pointer L, and then it will have a bunch of more things, but we don't need to think about that right now. What we need is a void update here and a void render for each state. Also, we'll add the private and the public sections, and this will be enough for our testing just of now. So let's go ahead and define update and render. We will also add a few things here like the state constructor and the state destructor, and here we'll do the same things that we did in engine earlier. As we define these, go into your state.cpp once everything is defined, and we'll start doing things in here. The first things first, we need to initialize Lua. So init Lua state, we're going to do this L equals Lua underscore new state. And remember to do Lua L underscore new state, because that's the faster one like we talked about before. Once that's done, we need to of course do the L. We need to do a Lua L load or open libs into our state. And this is an initialize Lua state, but we haven't initialized the entire state yet. To do that, we're going to need a file name. So each of these states are going to contain, or they're going to load a state file that is actually a Lua file, and that will be perfect to do std string Lua state file. You can set this to a char const char pointer if you'd like. We can do that. That's a little more old school, but that works just as well, because Lua is made in C and it connects well with C. So C things are a lot better to use when it comes to Lua. Once this is done, let's create an int error, and let's say Lua underscore do file, Lua L do file, this L, and then boom, we'll load the Lua state file and remove the const char part, of course. Once that's done, let's check if there was an error. And anytime there's an error, there will be a string pushed onto the Lua stack on the top, and you can print that string out from anything that actually throws an error from Lua. So let's print that out, std cout. We'll do Lua error state To get the top of the stack, we need to remember what we talked about in the Lua introduction. We need to do Lua toString. That will get something from the stack, toString, and we need to get the top of the stack. To always get the top of the stack, what we can do is we can write -1. That will easily give us the top of the stack. And we'll use this kind of thing here when we're talking about Lua errors, but we also have C++ errors. So for that, I'm gonna go ahead and do a throw, and in this throw, I'm gonna write CPP error state, what class I'm in. So this is just the way I do errors. You can do it any way you want. So I'm just saying it's C++, it's an error in the class state, in the function. So in our case, it's constructor, and then the actual name or the actual error that occurred. So we could not open a file, could not open file, and then we'll do a S like that. And this is how you format old style strings. So if I write %s here, this will be switched with whatever I write after the comma here. So I'm gonna write the Lua file name, Lua state file, and that will be substituted into this %s. Now we can throw some errors. What I need to do as a last thing is I need to pop this error message off the stack. Actually, I'm gonna pop everything off the stack because we're still throwing everything. So I just want to pop the state. Let's do that. Let's say Lua pop, and here we're gonna give it our state and say how many things I want to pop from the stack. So I want to pop everything, and to do that we need to get how many things are on the stack. And remember, get top is a great way to do that. Lua get top this L. Now remember, get top is not the top value on the stack, it is how many values are on the stack, and pop is asking for how many values to remove, so we'll remove all of them by doing this. And then we'll throw this nice little string to our C++ side. Great, now we're handling this. One more thing we need to handle is, of course, if there is a problem with new state, but we can do that by checking if this is null or not. We'll do that later on. We don't need to stress about that. Most probably this will work. Let's just close it. Let's just close it in the destructor. This is very important. You really want to close your state in the destructor, otherwise you're going to keep it open. This is the beauty with states. We want to be able to pop and add states dynamically. So that means we'll have to free up the memory here. We're going to update and render. And remember, we have an update function in Lua and a render function in Lua. These are the things that we want to access. So to access something from a Lua file, a Lua function, to call that through C++, we have to get it from the stack. So whenever we add something like this, it will be registered as a global in Lua. It's not pushed up on the stack exactly, it's just registered in the Lua state. So we have these two functions registered. I want to push that onto the stack so I can access it in C++. That's the two steps we need to do. First of all, we need to put it on the stack and make sure that it exists. So we're going to do Lua get global this L, and here's very important to remember the name of the function. So if you have a big letter here, we're going to use big letters, capital letters. You need to make sure it's very, very much exact here. So I'm going to do update, not update with a small letter, but with a capital letter. Once you do that, that will be pushed up on the state or on the stack, and then we need to call that. And the way we do that is we do Lua p call, and then what state we want to call on, and then how many arguments, results we're going to get, error function, all that stuff. We'll just do 0 on everything because there's nothing really we're pushing onto the stack while calling this, and we're not doing anything. So just write zeros here. Of course, we need to check error. So int error Lua p call. If error, we'll do the same thing. Now we can just copy paste pretty much what we did here and paste it in here. But now the error is in state and in the function update, and I forgot to add constructor here. There you go. And here the problem is an update, and then it will just automatically get the string. It will pop that error message and all that, just like we wanted to. But here the error is a little different. So it's not in the constructor, it's in the update function. And the problem is that we cannot call the update function. Cannot call. So this will give us a nice message in C++ in the console that we had an error. So that's good. You don't need all this error stuff if you don't want it, but it's a good habit to have. As much info you can get from an error, the better. Perfect. Now we can copy paste this. Instead, in render, we're gonna call the render. Whoops, not that easy. There you go, render. And then of course we need to change this to render, and cannot call render function. We don't have so much else in the state. We only have our Lua state here, but the beauty is gonna be when we add our sprite vectors here, we're gonna add textures here, controls, all kind of stuff, and you'll see the beauty in this structure very, very soon. I promise you guys that. Next step is to add the state into my engine. So include state.h. Let's make this a state machine. Let's add stack to pch.h because we need that. Include stack. Once we have stack here, we can start creating stacks, and having a state stack is the best way, I think, because you can automatically push and pop from the top. Any state that's on the top will be updated. If you pop that, the state under it will become active. So it's very automatic in that sense. You don't really have to think about much. So let's do that. Std stack state pointer. Very important that it's a pointer, and I'll just call it states. Now we can use our init states function to actually initialize one state directly up onto here. We don't have a Lua state, so I'm going to remove that real quickly. We're not going to need that just yet. We just need our regular states. This state is going to take a name or a file name, and we already have a game state file name. So let's go ahead and do this states push a new state onto the stack, and we'll say new state like that, and the Lua state file name, and that's going to be game state lua.lua semicolon, and you're good to go. Boom. Now we actually have a state on top here. When we're going to update, we're going to say this states.top update, and the same thing in render. So we're taking the top state and updating it and rendering it. So any state that's on top will automatically be updated and rendered. In the destructor, we need to actually just pop everything and delete everything. So while this states.empty, while it's not empty, let us pop each state. Delete this top states.top. It's very important to delete it before you pop it, because you have dynamic memory stored in each pointer in the state. So you need to delete that first before you actually pop that pointer. This states.pop. And this will completely empty out the entire state array here, or state stack. Now that's done, you should be able to start this game. But before we do that, let's go to our main, and we'll see that we're catching an exception E here, where this is going to be exception like that. And we're gonna actually create another one here. And this is not gonna be std exception, it's gonna be a const char pointer E, and this is now going to take a string. This is going to be a string exception. That's why I'm doing this, to differentiate these. Exception. Running this now should yield us with some errors, if there are any errors. No, there were no errors. We have hello from Lua, update and render. So what is happening now? Let me just walk you through it quickly. This file is loaded when we create our state at this point in the engine, right here. When we push it to the new state, this file is pushed to our state. Right? And what happens in our state constructor? Well, it does a Lua do file, and the do file calls or opens this file and registers everything that is in this file to this state, the Lua state. And the update function now gets that state and pushes onto its stack the update function that is registered here. So that's pushed onto the stack. We call it, whatever is pushed on top of the stack, pcall will call that. That's why this can be a little confusing. Lua works in this way. Whatever is on top of the stack, if you do a pcall on that, it will try to call it as a function. We'll try to access that. So since I put Lua update on top, the pcall will call that update function. So we'll go in here and we'll do anything that is in here. Of course, if there's an error in that call, if it's not a function or if it's a nil value, it will say that here. So let me just show you guys. So if I remove those and I run it, now we'll have a bunch of errors. So Lua error state update attempt to call a nil value. Anytime Lua cannot access anything, it's a nil, and that's like a null. So this nil value is being trying to call because there is nothing called update on the stack or in Lua at all in that state. And then we'll get the CPP error as well. String error, cannot call update function like we wrote. So that's good. Now we got a lot of information. That means we need to create an update function and a render function, and voila, you're good to go. There you go, guys. That is pretty much it for this video. We have created the main structure that's going to help us create our game. We're going to create a main menu state. We're going to create a bunch of different types of states, button class. It's going to be really crazy this series, but it's going to be really fun to do. So thank you for sticking with me. Hopefully we can get into some graphics, some Windows stuff just coming in the videos now. And yeah, keep learning, stay on top of things. I'll see you in the next video. Bye-bye.